Very much for inviting me and to the organizers. This is joint work with Mirko. This is one of these papers that we're very happy to make a simple point, and then we spent the last year getting data to comply with the standards of the profession. So, we'll get stuff done eventually. But I'll show you kind of the first suite of results on that. The paper started with a very ambitious goal of understanding the long-term effects of DARPA program in the US. After many months of lobbying, they did not take it down from top secret, so we did the next best thing. So let me go from general to specific. So, many of you in this room are familiar with the notion of demand-led innovation, that the extent of the market governs the amount of innovation, going back at least to Schmuckler. If you narrow that down a little bit, you can think about one portion of final demand being government, and therefore you could think about government-led innovation. There's been especially popular, more popular books, but some research on what that quote is representative, that a lot of the technology you currently own was actually initially developed in some government-funded project. All right? And that the government created the space for that innovation, created the market for that innovation. All right? And one particular important aspect of government demand for innovation is the defense spending-led innovation. So I know a lot of you care a lot about R&D subsidies. R&D subsidies are minute with compared to the amount of R&D purchases by the military over the decades. Right? So there was a study by the National Science Foundation trying to account, in the post-war, of total post-war R&D developed in the US, how much was directly funded by defense departments in the US, and that's about 20%. It peaks in the 1950s to 30%, right? So it's kind of a major policy tool, even relative to kind of the more standard subsidies, right? So we're going to kind of focus on this. So that's the area where we're going to be working. So the first question is a simple one, which is kind of what is the impact of defense spending on innovation outcomes for the people that get to supply, the people get selected to supply the government with such contracts, right? And then the second question, which is where Mirko had been working on the first question, and I had been thinking about the second question. The second question is a simple point. You tell me if you've seen it before, that these market size effects should be recursive or cascade through supply chains, and we'll go a little bit through that. And can we expect that innovation cascades through the supply chain? So the fact that some firm gets to supply the government, say, with an R&D intensive contract for the Department of Defense, do the suppliers of those firms have incentives to innovate as well? And if so, that kind of, another way you can think about this is in a sort of kind of multiplier effect, right? If you think that the full effect is summarized by question one, are you wrong and by how much? Because you're failing to do spillovers through supply chains. Okay? So that's kind of the desiderata for the paper. How are we going to do this? It's going to be a very applied paper. I'm going to show you a very simple theoretical argument, but completely pedestrian and flooring in face of the good models in the room. So what we're going to do is actually one of the best data sets in the world for procurement contracts is done by the Department of Defense in the US. So this is basically contract by contract, the universe of all procurement contracts by the Department of Defense. Okay, and we're going to go a little bit about that. I'm going to try to convince you that there's room to interpret this as market size increases, right? The government asking for actually completely new products or product innovation in particular categories. For example, when the US government was fighting a war in the desert, They all of a sudden needed all computers to be upgraded so they could withstand fine desert sand and 50 Celsius, right? And that means that someone has to come up with the engineering and the patents to do all that. And I observed the winners of those contracts. So I'm going to try to kind of trace back what happened to those guys. The second point is this kind of cascade or dividend cascade, innovation dividend cascade. And the point is very simple. By the same logic, you would consider a market size effect, that typically we would think about some kind of final demand story, right? Pharmaceuticals, et cetera, et cetera. That's in principle should translate to an increase in derived demand for intermediate inputs of the firms that scale up their activities in response to the original final demand market size increase, right? And once you have that derived demand, that is their market, so you should expect market size effects working up the supply chain, right? And that's kind of the view we're going to take. Government is the final demand. It will push, it will increase the market size in some way, in some area of the technological space, and we're going to try to follow that through the supply chain. All right? And for that, we're going to have some information on the supply chain of Department of Defense contractors. All right? And we're going to go look at the innovation outcomes of those. All right? So let me bring you to a particular example. This is one of these, the military economic state or apparatus in conspiracy theories. This is one of those. There's a firm called General Dynamics. If you've played computer games in the 90s, you'll recognize all this from like amazing computer games. They did everything for a while in terms of kind of conventional fighting, all right? In particular, it was a major contractor during the 80s for the US. They're still around, they're still big. They're a global firm, actually. You can see here, this I pulled from their webpage, and they had some contract in Mexico. I guarantee you see it, et cetera, et cetera. Now, we can go to these Department of Defense contracts and actually see them winning those contracts, right? And you can actually see the amount of what we're going to call defense dollars getting into this firm, right, by winning contracts. Now, that firm happens to be publicly listed, so we can link this to Compustat, and we can look at their balance sheet data, and then we can merge in NBR patent data to see what's happening with this firm in terms of R&D, sales, patents, quality weighted patents, etc. All right, and that's what you see. So obviously the correlation is pretty high. Obviously you should worry about reverse causality. Obviously the government is trying to hire, sophisticated high-tech firms. So the movement could come from previous innovation dynamics by General Dynamics makes the government open a contract because it's now possible to do this. For today, we're going to do a pretty pedestrian strategy. We're very excited about a new strategy. I can tell you a little bit more at the end if you want. But we're going to source a little bit from the history of US military spending. And US military spending is both characterized by large cycles. There's moments in the history of the US where they spend more than others. And the second part is it's characterized by large shifts in the composition of what they ask for. All right? So we're going to interpret these kind of shifts in the composition as largely determined by global politics, global strategy. And we're going to think of these firms as kind of specialized. We know that they are specialized because we observe all of their contracts in the past. So we can observe kind of what is the portfolio of technology that the firm had, particularly in the firm that had in the past. Right? And we're going to use that measure. I'm going to be a little bit more concrete about this to say what is the potential market size at any point given lagged specialization dynamics and current government expenditures in a given area. Right? You could think about the probability that this firm is now competitive, at least, for a particular bid. So we're going to go through that. And that will be kind of our instrument Obviously, we selected one that looks particularly nice. It's going to work. All right? There are worries, and I'm happy to talk more about this. That's one part of the data. That's kind of the contractors that win. Now, what happens in the US is if you're a publicly listed firm and you have a customer that accounts for more than 10% of your sales, you need to report that information to your shareholders. And that information is recorded, so you can go back to kind of publicly listing by reports by publicly listed firms where they have to actually report who they're supplying if they're big customers. So we went to say, you can go to this data and say 1990, who is saying that General Dynamics is a big customer of that? There are about 10 firms like that. I should have put labels, right? So these are like direct suppliers, or you could say they're distance to in some kind of graph theoretic sense from the final demand. Right? They're distance 1 from General Dynamics, they're distance 2 from the government. Right? And then you can see who the suppliers of those suppliers are, and then it gets a complicated mesh where firms supply to each other because that's the way the economy runs. Right? But now we have, to the extent that these are publicly listed firms, we can do the exercise all over again. We can see their R&D and patent outcomes, right, from their supplying winning a particular contract. And that's basically the paper. I'm not going to spend a lot of this. I guess, the point that I actually like the most is that we've been thinking a lot in economics about technology spillovers over the years, and we typically think about, osmosis. It's in the air, right? It's, a firm patent, and there's some kind of externality that we don't think too much, and then some knowledge space, and everyone gets to be more productive. This is a pecuniary externality, if you wish. Right? This is something going through derived demand. Right? There's allied areas studying supply chains, and of course, people in this room have actually did great work on market size. So I'm going to be the message, the mechanism is super simple, so I'm going to do the simplest model I can. I think there's interesting stuff to do in a proper growth context. I'm not going to do that. I'm just going to tell you, tease out a little bit this mechanism that I'm telling you about. And I'm going to go for the simplest supply chain in the world. There's an upstream firm that supplies a downstream firm. That downstream serves final demand. All right? So let's think about their technologies. This is like a upper level undergrad exercise. The downstream firm, let's make it super simple, faces 1 unit of final demand, requires for each unit of final demand it serves, the technology requires 1 unit of the intermediate input plus some processing costs. All right? The total cost of producing that unit is therefore the price of the input it buys, I'm going to call that X, plus some cost borne by the firm in producing the final demand good. And I'm going to say that, in the simplest way possible is I'm going to say that the firm can expend resources to reduce that cost, right? That cost to produce. And that cost reducing innovation has decreasing returns, meaning, the more you put in, the lower the cost, but you get benefits at a decreasing rate there. And the simplest way to close this on the final demand is to assume some kind of linear demand curve. That's just an inverse linear demand curve. Right? Now, what does the upstream firm do? This could easily be generalized to many upstream firms, many layers of upstream firms. Nothing much changes. So let's make it super simple. How do we do that? Let's say that the upstream firm actually produces with no inputs. It's a pure processing. Right? It just creates the good with some cost, the intermediate good. You could say of labor being held fixed factor here if you want. So that now that firm can also do cost reducing innovation. In particular, it can expend resources K upstream again under the same decreasing returns. All right? And the final good firm is the only source of demand. That's super easy. How do you solve this? You can say, you solve the model backwards. So you can think about this happening in two stages. You decide the quantities of R&D spending. Once those are decided, you decide on quantities, conditional on the level of R&D spending. Solve for the last stage, backward induction. I just want you to convince that you are able to prove a little proposition like this without this typo. This is for A large enough, all right? To avoid multiplicity of equilibria, actually. It's technical. So first of all, what is the comparative statics that I just want to have clear in your mind? Suppose that the final demand shifts. Right? An exogenous shift to the final demand, I'm basically saying they intercept a parallel shift. What happens at both downstream and upstream decisions? It's actually laborious, given how simple it is, but you can easily prove that downstream and upstream profits are increased, downstream and upstream quantities are increased, and downstream and upstream innovation increase. Right? So you've turned a final demand increase into a sequence of higher innovation activities going up the chain. Right? So these are market size effects. Right? The only thing that changed was the extent of the market. For the same price, there is now a larger market. So the upstream firm is exactly what we were saying before. There's just a derived demand increase. Right? It's just a final demand market size effect in a setting with production link intermediate inputs being traded translates into derived demand increases and for like cascading market size effects. The downstream firm gets the traditional market size effect and under mild conditions, that I actually didn't put this, has a cost reduction effect because the upstream firm is now producing at a lower cost. Okay? So this is pretty simple. I think to understand this, you don't need any more complicated model. I think it would be interesting to think if you say put this in a growth model, in the endogenous growth model, it might have interesting implications. Perhaps everyone knows I'd never seen it made a very simple point. The rest of the paper is really about kind of thinking about these market size effects and derived demand market size effects in the context of defense-led spending. We are working on various extensions of the model, nothing that I thought of bothering you with. Let me move to the data. So I basically want to think through these basic mechanisms in the data that I have, and which is pretty rich. So let me go back. So this is every single expenditure, every single procurement contract by the US Department of Defense over a period of basically slightly less than 40 years. We've now extended the database till 2010. That's one of the things we did during this year. It includes all DoD purchases above $10,000. And you have information on the contractor name, the location of work, the dates of action, estimated completion date, the contracting office within the DoD. So it's pretty rich. We're actually not using most of this. What we are using is a very nifty, very detailed, very military product coding classification system, because then that it will allow us to have these notions of portfolio and spending across different areas by the government. So you can see, these guys that's what they do, right? They procure stuff. They classify what they procure. They can procure nuclear ordnances. They can procure, ball bearings. They can procure railways, airplanes. And this is the 2-digit code. You can go down to a 4-digit code, and you can see them procuring nuclear bombs, nuclear components, parachutes, kind of very detailed product market. All right? They also procure tuna cans for the troops. right? So it's all in there, actually. This is like a brief history of the world. This is the petering down of like the 50s and 60s build-up, all right? Kind of first wave of the Cold War. This is Reagan, the first wave of Make America Great Again. It was there, right? Star Wars. We're gonna bomb the planet from the outside. And then and through the end of this current sample, you start getting Gulf War type stuff, right? And even if it's at a very low level, but you should remember these are very different wars. These are very different things, right? These are the transformation of the U.S. from standard warfare to fighting in deserts and fighting against non-conventional troops, right? And that's if you move, that's what we're seeing in the data. You start what you want counterintelligence, communications, and stuff that enables you to be swift in pursuing small groups of terrorists. This is space Star Wars. This is much more conventional tanks, airplanes, boats, right? And this is at a pretty high level. All these micro product categories are changing all the time, right? And we're going to use that. If you want to know, at the 2-digit level, tuna cans for the troops, subsistence, all the way to pure R&D contracts. So, if you might know American academics that are working for NASA, and they're in a university, they're working under an R&D contract, right? It's kind of the pure development. And there's kind of a range of what is a completely new product to what is probably just like marginal product, marginal or even non-existent product innovation, right? Tuna cans for troops in the desert, right? Okay, so that describes the procurement data. This is what I told you before. This is where we get remember we observe the winners. So how do we observe the suppliers of the winners? Again, it's this rule that if you're a publicly listed firm, and if you have a very large customer, say if you supply to Walmart typically appears there. Why? Because normally Walmart is very big and it's a big customer of even very large publicly listed firms. And they need to report that to their shareholders because it's a source of risk for the firm. All right? And that's available in this segment file that I was telling you. And again, we're updating this. I'm going to show you results today for like these 30 years, and that will naturally truncate what we can do in these early years because we don't have that data. And these are basically read from SEC filings. So they're official. It's obviously full of biases, right? If you think of the way it works, these are publicly listed firms that have customers that are very large and also publicly listed. That's how we're going to get them. All right? But I think for what we're doing, it works. If I was in some other project, just to acknowledge that Ali Ortasu and Engen Atalay actually gave us the data, shared us the data, and they have like a really neat paper in the PNAS. They were kind of the first people to look at this seriously from a network perspective. So then it's just a giant merging exercise. So we have, there's a first kind of text matching algorithm. We have the contractor's names. Sometimes we have to match that to the ownership structure of that group so when we know which firm is actually publicly listed. Then you run a text matching algorithm and you find that firm in, say, CompuStat. All right, and then you get about 80% of the total dollar value matches, 95% for these very important R&D contracts. Once you have those, you can merge in the NBR patent database. You can just do standard counts. You can weight patents by their importance, taking into account the citations as usual. So what you get out of this, you get a panel of listed firms matched to defense procurement contracts along with their supply chain information, all right, for about 30 years.
So you have multi-product firms here, right?
For sure. I have.
And you can probably track the effect of a shock in
That is a very good idea. We haven't done that, but that might be a source of noise in our measurement. We should think about using that information. So the only thing I want to say is, just as there is the customer segment file, there is the product segment file, which divides the company into, which product areas are they operating, what is the share of sales for General Dynamics and airplanes. I don't think we're going to need to use that, but we might use that in other creative ways, but you tell me. And I'm not going to use it now. So I'm going to call Mirko picked this, I don't like these names, the final demand firm and the supplier firm, or the upstream firm. And one thing that I want you to be in your mind, perhaps you can tell me how I'm biasing my results left and right, is that these final demand firms are much larger than their suppliers by design of, by sample selection. All right? And they're also, they're larger, they have more patents, they have more citations in almost every dimension. Okay? Though you have like this, I guess, ufuk finding of smaller firms being a little bit more intensive if you want. Okay, so that's kind of, we get this data. And now I'm going to do something very pedestrian. So I'm just going to look at a panel outcome. First, I'm going to just do correlation. So I'm going to regress some outcome at the firm level at some given time. That outcome will be sales. We've done profit as well, I'm not going to show you. R&D expenditures, patents, citation weighting patents. I'm going to look at those 4 outcomes for today. Of a given firm, I'm going to put a firm fixed effect that should deal with like level effects of some firms are just more innovative than others. I am going to control for kind of an industry time fixed effect, so we are emphasizing stuff within industry, not secular trends of kind of technological innovation across industries. So those are buried in here and here. We've tried with a number of actually firm level controls if you want. And then for the correlation, the variable of interest is, the size. Did you get a contract, and what is the size of that contract if you got it? Okay? So this actually, we are currently working on this. It merges both extensive margin, guys that didn't get it, and guys that had contract and get more larger contracts, okay? You should have a concern, obviously, about this upward bias coming from firms getting contracts due to unobservables by the econometrician. We'll try to deal with that with a very pedestrian strategy. We're actually very excited about something we're doing. So what is that very pedestrian strategy? You can do something very simple. So it's basically a bar-take instrument. Right? So remember, firms have pre-existing specialization in particular types. Right? So let me show you, for example, Lockheed. And I can go back in '72 and say, what has Lockheed been getting contracts in its history until then? Not surprisingly, they basically get airplanes and have R&D contracts and missiles. That's what Lockheed does. Okay? So you can now say, if the government is looking for this sort of stuff, then Lockheed should be a likely winner. Right? So what is it we're going to do exactly? We're going to add another premise, and we actually have, I can tell you a little bit about some things that might assuage you on this. The second premise we need is that no particular firm is kind of affecting the level of current demand by the Department of Defense. And so you cannot believe in super big conspiracy stories. All right? And what are we going to do now? Let me just take you to the actual nitty-gritty. It's very, very simple. I know all the previous contracts, and I know their product codes. Right? So I'm going to form Lockheed in 1972 had that portfolio I just showed you. Historically, 40% of its contracts on airplanes, et cetera, et cetera. I am going to use that information for, and I'm going to lag it. All right? So this is to try to limit anticipation effects. I'm going to say this was the portfolio of Lockheed 5 years ago. Right? And now you can see how much is the government today currently spending in each of these product codes. Right? Not in Lockheed itself, but in the product codes. Right? And by this, we simply go back to this idea of saying, you know, the government will shift to Star Wars and it will stop asking for 5 minutes, airplanes, and will move away. And therefore, this should be an instrument for the latent demand given the specialization of the firm. Right? And we can add up, so this is what I just told you. Right? So we know the shares of Lockheed 5 years ago in every area. We know the current spending. And we know that if they have big shares in areas where current spending are low, they're very unlikely to get a contract. If they were specialized 5 or 10 years ago, it works the same. And in very big areas of current spending, then they should be very likely, right, given their past history of specialization. Right, so let me go back the last 5 minutes, so I'll just show you results. I guess this is, I just came out of a severely theoretical paper, so I never know how you present empirical. I left the last 5 minutes for results. Okay? If it's not like that, just let me know. So what is the correlation, basically? So a 10% increase in the amount of defense dollars the firm gets increases total sales of the firm by about 0.5%. These are not massive things at all. It increases patent counts, it increases cited patent weighted by citations, it increases, remember you can read this of CompuStat R&D of these firms. Right? Remember I can use this IV, right? This is the kind of Lockheed instrument, and to instrument for current defense sales that they're actually getting, and the OLS goes slightly up. And the first stage is strong. All right? So remember, we have a host of fixed effects working at the time industry level, and it's also robust to a host of controls. I'm going to now go to the upstream effect. So what is the upstream effect? Remember, I observe in the data the share of inputs that customer K purchases from supplier I, so I know how much Lockheed, from the total cost of goods sold of Lockheed, how much did he spend in one particular supplier. I can compute that share. And now I can make an assumption, obviously I don't know if this is true, that for each dollar the government pumps in, that percentage, so for each dollar the government pumps in, multiplied by the share of the importance of that supplier to Lockheed, will reach that supplier. That supplier might, I actually observe him in data, he has multiple customers. So I'm going to do this for each customer he has and sum across customers. And that will give me the total dollars that that firm got through the supply chain from defense dollars, right, in a given year. And then I can do the same race. Sometimes I observe these firms are both suppliers and direct winners, so I'll have to control for that. I'm going to do that right now. And this is what I observe. I observe that, so one final thing that I didn't tell you is, obviously there's lots of firms that are not direct suppliers. They're suppliers of the suppliers of the firm. I can continue playing this game, right? I can say, this was the final demand increase. That was the share in this first stage of production. I can multiply again by another share, which is the share that gets me to the second stage of production, right? So, in fact, this is not only the first round, it's all n rounds, right, that I can observe in data. And I aggregate this, all sources of defense dollars flowing through me indirectly. So that's what I get. Again, the sector, time, fixed effect, blah, 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 blah. So, remember, I need to control for all firms in the database I get direct. Some of them coincide with being also upstream. And this is what you observe as the, OLS effect on upstream firms. There's a couple of ways you can rationalize it. One is attenuation bias. Right? I am assuming that they get exactly that share, right? But I might be observing a firm that does shirts for Lockheed, and that firm will get no added increase from contract for super duper fighter. Right? It also is the case that I'm assuming that those relations are sticky. Right? The firm could also just lose Lockheed as a supplier as a result of the government shifting what Lockheed wants to do and what suppliers it wants to have. Right? So I think there's good reason for this to be a smaller effect. Again, you can do all these, and I think this is the estimate that Mirko likes. And I can also IV this, right? Now I can IV the final demand increase by exactly the same thing and do the IV upstream. Interestingly, that's like the last geeky thing I'll tell you. Remember the OLS and the IV changed quite substantially at the final demand stage, at the Lockheed stage. Right? And that's why we would worry quite a bit about endogeneity, and maybe our instruments should do something. Upstream, it's much less likely that you're getting a derived demand increase and that the government is thinking 2 and 4 steps ahead in the supply chain, that you want to target you as a supplier of the supplier. And in fact, these estimates pretty much coincide. All right? Last thing I want to tell you, this is consistent with other papers, and I'm going to finish. These effects are actually relatively small, okay? Especially for the upstream effect. Now the question is, for each downstream firm, there's, in my data, and that's pretty selected already, there's like 10 suppliers. So these effects, if you aggregate up just in a simple weighted by their size, this kind of cascade consideration augments the total effect, say in, I think this refers to R&D, probably, if not, it's patents. We have the baseline effect of the market size effect on the final demand firms. It augments that by a third, taking into account the other firms. Those numbers would not tell you that. Those numbers are much smaller than that, but there's many, many of those firms. Right? It's a typical network argument where a shock hitting one particular firm will reach many of those because of supply chain relations. Right? So that's the paper. We're doing a bunch of stuff. We are digging lawyer data to find losers of the contracts, and then we have winners and losers, and that allows us to do a different type of identification. We have extended this. We are doing a quadrillion robustness checks, and we will satisfy each and every one referee eventually.